is Ievgen. I work for the European Broadcasting Union. It's the union of public service media broadcasters. It's called European, but we actually have members around the world. We have associate members in Canada, in North America, in Australia, in Asia, even in Africa, I think. But not here to talk about myself. I'm going to talk a little bit about the initiative that we started for the previous NAB in Las Vegas, and we successfully continued it this year for IBC. So that is the JTNM tested event. We're going to talk a little bit about what it is, what did we do, how did we do that, why would we do that, what was the results and outcomes and findings, different things, survey and conclusions. Anyway, so what is JTNM tested? JTNM stands for Joint Task Force on Network Media. It's the alliance of it was established by 4 companies, the AMWA, the EBU, the SEMTI, and the VSF. You probably heard about some of them. For those who hasn't, just Google it, okay? JTNM Tested is the initiative that we launched, as I said, at NAB. The idea was we had already a bunch of interop tests for different open standards for AES 6.7, for 2110, some Plugfest, Dirty Hands workshops, and all those were good. Those were all good R&D efforts from the vendors and by vendors for vendors. As EBU, we are the community of users, so end users, the buyers of the actual equipment, the users and the engineers who design and implement those devices, not necessarily the standards themselves, because we then rely on vendors to implement them, and we build systems on top of that. And we saw that there is not a lot of transparency, not a lot of openness towards the user communities from the vendor communities, and we said, let's change that. And we created a JTNM Tested initiative that offers a greater and open, transparent documentation of the Plugfests and the standardization of 2110, 2059, and this time for the second iteration of the program we included some control plane standard specifications, especially AMW and MOS. You heard about that throughout the previous presentations already, and the JTNM TR1001. TR stands for Technical Recommendation, named numbered 1001-1 stands for the first iteration of that. There will be a lot of abbreviations in the presentation, so in any case I encourage you to scan the badge, get the slides, Google those abbreviations that you don't know, go on the website, there will be a link on a couple of slides that give you the actual results. I'm going to talk about that. So we produced a bunch of documents, and it's important to understand that this is not a certification program. We do not say if this device was tested by the JTNM that we certify that it's absolutely going to be interoperable in your infrastructures. Unfortunately, we were not able to do that because neither JTNM nor EBU is the certification body, is not an authority to provide like a IEEE certification or some other things like that. We only said that in that particular environment that was duly documented in the test plan, for that particular firmware, that device behaved and performed like this. And in the report, you'll actually see which tests and under which conditions were performed. We in this time we provided 3 types of tests. So the basic data plane, so the media transporting media from point A to point B, but also a control plane, telling the devices to initiate the media stream and to join the media stream and to request media stream, discover media stream, and all that provided by the ANMOS and TR1001. I'm going to talk a little bit about that, but we also did a cybersecurity vulnerability assessment, which came as the icing on the cake. It wasn't part of the official test plans, and we used some EBU documents for that. But we also recognize that cybersecurity becomes more and more important in the context of media moving to traditional standard commodity IT technologies. So we had 32 vendors attending the beautiful facility of Real Communications in Wuppertal, Germany. And 71 products in total were tested, including 34 of them for the control plane. So some of you may be familiar with the Pyramid It's literally now called, it's actually an EBU publication. It's called EBU Tech 3371, but it's now being called just the Pyramid. Everybody knows them as the EBU Pyramid. The EBU Pyramid is the collection of user community requirements towards the industry of what we think is important to have in the media over IP device for open interoperability and for the actual usability. So again, I don't have a link for that, so I'll repeat for those who will be watching the recording afterwards. This is EBU Tech 3371. Just Google it. It will give you a PDF that explains which layer stands for, what were the drivers to include that particular technology in a particular layer. But what we did, we tried to map the JTNM activity into the pyramid, and we said that the first one and the 2110 test plan that was already performed for the previous NAB and for this IPC maps somewhere in between the media transport and synchronization, covers those two layers. Then we introduced the ANMOS/TR1001 test plan, which is the second iteration, and we covered the yet another couple of layers of the pyramid, and the cybersecurity testing is also covering yet another layer. So we produced a bunch of documents, as I said, supporting the program. The main publications were the actual test plans. What is cool about the test plans is that while we were using them as the guidelines for our testing, there is absolutely nothing that prohibits you from getting the test plan and using this test plan in your R&D process or in your proof of concept process when you're building or designing a solution. You might as well just use this as the criteria for benchmarking your particular piece of equipment. And those test plans are for the 2110, including audio parts, of course, because we're in the audio engineering conference. Sure, we don't care about video that much. But also the control plane that is of interest, of course, for audio engineers as well, because GlobCon, as the previous presentation, is yet another effort to standardize control and stuff like discovery and registration. So as an open protocol in that field, ANMOS stands for Network Media Open Specifications, and it's included in the TR1001. Again, just Google those and you will get a bunch of multi-paged documents written by people way smarter than me that will explain what those things are and what they're designed for. And for cybersecurity, we use the existing EBU recommendation R148, which is pretty much, again, the test plan for evaluating and doing cybersecurity assessment of a device. Some pre-testing documents we provided for vendors to make sure that they are able to prepare themselves for the testing, explaining how to use the tools that we're using, how to capture the stream properly, how to use the EBU Live IP Software Toolkit. Again, just Google it, EBU List, you'll find it. EBU List stands for Live IP Software Toolkit, and it is the suite of tools designed for benchmarking and at some point real-time monitoring of the IP streams in 2110 environments. It also tests some ANMOS capabilities, but for that we actually use the official ANMOS test suite provided by AMWA. So again, that's talking about the tools a little bit. In terms of 21 test plan, we tested a whole bunch of standards from the suite. So as you heard around the show already, the 2110 is not a document, it's a suite of documents. For audio, we tested the -30, including some audio validation. So of course, not only reporting that you're decoding the stream, but also actually decoding the stream, which makes sense. We also tested the -7, 2022-7, which is the multi-port redundancy introduced by 2110. So you probably have seen some audio consoles and audio devices around the show that have a dual port for multi-port redundancy. Most of them, at least in the ecosystems that they're designed for operating, they do that in a proprietary way, and even in AES 6.7 interoperability, there may be challenges with the dual port redundancy. So 2022-7 actually comes in and says, okay, if you're doing multi-port redundancy, you're going to do it the standard way, which is good. And we also did this time some UHD testing, because UHD, future, 2019, okay? For the TR1001, the control plane, we tested a no-brainer things like, can device support DHCP? Can device do LLDP? Which is important if you're using tools for for example, for automated topology building. Those tools rely on linked local discovery protocol. System resources, automated configuration, ISO 4 discovery and registration, ISO 5 connection management, and ISO 8 audio channel mapping. Again, just Google them. I don't have time, unfortunately, to explain you all of them. So, findings and results. Again, here's the link. If you go on the link, you will get not one, not two, but 3 reports. So, don't delay, download today. You'll get a report from March 2019, so pre-NAB, the first iteration of the program, and 2 reports from August 2019, which is the 2110 and the control plane. At this point in time, I usually invite my colleague Willem to talk about the results, because unfortunately it's a lot of statistics. In any case, when, not if, but when you go and download your reports, you will see something like this. So you will see a list of devices that published. You will see the version of the firmware that we recorded at the time of the testing. So we said these results are valid only for this with this version of software and hardware, and the requirement was that actual software and hardware are the production, not like R&D beta engineering version. No, you have to actually ship this firmware so users can access it and they can expect this performance. You'll get a bunch of color-coded results, and the green check mark means the test is passed. Everything's good, all good. The white one says this device cannot do that, so the test is not applicable. Of course, you see a bunch of whites, for example, for video tests that are applicable for audio devices. Of course, audio devices are audio devices, they will not do videos, so we didn't test that. The gray ones are a bit worse, so this means the test was not successful, either because it just failed, or the vendor said, I would rather not test that. You read between the lines afterwards. And of course, all the tests on top, they map directly to the test plan. They numbered according to the test plan, so the test catalog, you will get the actual test plan and the results spreadsheet. So you can actually see, okay, test 212 was that one, and you can actually go back to the test plan and read how we did that, what was the criteria, what were the results. So a little bit about statistics. I said 100% pass rate was from 31 out of 71 devices. All but 22 achieved more than 90%, which is good. Unfortunately, the worst test results were in -7 multiport for various reasons. It was a very aggressive test, so we actually introduced the impairment generator from Packet Storm, and it was hitting 25% of the packets on each link sequentially. And this is not something you will see a lot in real world, because it's either a very, very dodgy SFP or a very, very bad cable. But we thought that it's within the scope of the standard, so we might as well test it. So the most unfortunate ones were the KPIs that should be 0. So we were expecting 0 fail rate in the fundamental things like the -21 and the SDP generation. So those two are fundamental. If device is not performing according to the standard in the -21, again, this is a very complicated standard. It's a very particular one, so just Google it if you want. But we saw some failures there, which are unfortunate. So a bit of common issues, as I said. -7, not a lot of success. Well, disturbing fail rate, let's put it this way, in 21 and -10. Also because there is one ambiguity in the standard that we already talked to SMT about that, and we will try to resolve that. Not a lot of devices were supporting UHD, something to be improved. Again, it's a very particular beast, and if you're looking for UHD devices that will be of interest for you, you see for yourself. Overall, the success rate was much, much better than the previous one. Much better, like seriously, because vendors recognize that this effort is something that not only helps the users, but also the community of vendors themselves. Also, we introduced the mandatory self-testing, so we said, okay guys, you need to test your device in your lab, in your control environment, and submit the results of the test to us before actually coming to the face-to-face testing. And this resolved a lot of problems for them, and they said, okay, you made this mandatory, we actually did that, and we found a lot of issues that we were able to fix before the official testing, so our results were much better. So this is also a very good Q&A process for them. Pod testing, this is our internal stuff. We cannot. We are looking still to optimize the actual testing process. It's a commitment. It's a lot of. It's a big commitment from not only the vendors but also for the testing team, because it's a 1 week consecutive day-to-day testing of 70 devices against like 50 different tests, and it's a lot of work. So the control plane, usually we invite our colleague from BBC R&D to talk about the control plane testing, but he's not here, so you'll have to bear with me. Again, a similar principle for the catalog. You get the results, you get the same color coding, and you can go back to the test plan and read about the tests. A little bit of statistics, 100% pass rate, 6 out of 34 in global testing, so for all tests that were applicable to devices. 20 out of 34, which much better. It's for the fundamentals, so ISO 4 and ISO 5, which is the discovery and registration and connection management specifications. Those are critical, those are fundamental for usability of the devices, so very good. All but 4 devices, more than 90%, good results. Unfortunately, LLDP had the worst results. Not a lot of media devices support LLDP simply because we never bothered about LLDP, but think scale, think big facilities, big broadcast facilities that go all IP. We have a lot of, in the user communities, we have a lot of broadcasters who are currently rebuilding their broadcasting centers completely in IP, and they use those automated devices, that automated software that build the network topologies and monitor network topologies. So those rely, as I said, on LLDP, so that's important. That's why it's included. DHCP support much better, but still a lot of room for the improvement in terms of automated management. If your facility is completely IP-based and even camera has an SFP port, of course it is important for usability. We get used to things, just plug and play. You plug in your AS3 or you plug in your SDI and you know exactly what is there and exactly what device it will be expecting to do. When you plug in the fiber into the SFP on the camera, nothing will happen unless there is automated backbone that will tell the camera, your camera 1, this is your IP address, this is where you're supposed to be streaming, and DHCP is part of the equation, of course. So they performed almost 8,000 tests, and the testing was pretty much automated, which is good. Very common failures across devices beyond items which simply hadn't been implemented, which means that if a feature was implemented, most of the time it was operational. It was either good or not implemented. Okay. Some issues with ISO 4 UUID consistency. This is a very particular one in terms of, again, orchestration of the facility. If you reboot the device, the registry will look at the UUID of the device and it will register it accordingly. If that UUID is dynamically changing, which it shouldn't, then it means that the device after power cycle can be identified as a different device, which doesn't make sense at all. So that is a potential room for improvement. So again, this is beyond my pay grade, and if you want to know more about the TR1001 and NMOS testing, I encourage you to go on the VSF YouTube channel, and there is a recording of this presentation by Andrew Bonney from BBC R&D. He will talk a lot more about what tests were done in the test plane, so I encourage you to go on YouTube, on the VSF YouTube channel, and look at that. So again, some lessons learned. Stream and discovery testing. Some of them were not automated. They can be slow, they can be manual testing, but those are valuable tests because for the end users, this is extremely important. Pre-testing, again, for control plane, pre-testing meant a lot and made a big difference because vendors were able to fix the problems before coming to the official testing. And even more important one, the fully featured implementations were quick to tests. The tests were automated and they were relying on those orchestration features. As I said, LLDP, DHCP. If those were implemented, the test was like this. Otherwise, they had to manually configure everything. And this also shows that a fully implemented control plane is much more user-friendly and much more orchestratable, if that's the word, than manual configuration. In terms of cybersecurity scan, about 387 vulnerabilities found. Some of them were super critical, and we made appropriate follow-up with the vendors to fix them. Some of them are like, okay, but. So, of course, as media devices, we usually used to having only the management ports, and we don't bother because it's the isolated network, and who would in their sane state of mind would hack your playout server? But since all of them are becoming more and more on a commodity hardware, so we more and more see the playout servers as the OEM servers from Dell, from HP, from whatever, and those becoming integrated more and more in the IT infrastructures of the companies, especially when you build a full IP infrastructures. Some of them can be critical. So again, there is a... Seriously, guys? There is a whole report, and the whole report from a cybersecurity team was done at IBC this year. So again, VSF YouTube channel, look for the cybersecurity assessment from Gerben, our good friend Gerben. He made a whole talk about how they classify the vulnerabilities, how they perform the scans. This is also very interesting in terms of your own education, how you would assess your infrastructure in terms of cybersecurity. So afterwards, we run a participant survey that was very positive, and usually it varied between 4.6 and 4.8 out of 5 in the questions like, should we do that again? Was it beneficial for you? Was it valuable for you? So there is still a discussion ongoing whether we do it or not. But overall, the response from the participant was positive. Like, yes, we enjoyed. Yes, we benefited from that. Yes, we took some value from it, either a marketing or QA value. Potential future tests, if we're going to do that again, we're going to expand, of course. The audio-related one that's important is the 2110-31, so that's bit-accurate transport of non-PCM AS3 streams. It could be non-PCM, it could be PCM, so whatever you pack in AS3 can be transported in -31. And the -22, which is more important for video people. This is the standard for mezzanine compression for 2110. So big reduce in bandwidth needed. In NMOS and TR1001 testing, we looking into testing the actual registries and control systems, because this time the whole testing was for the end devices. So just to be clear, the network, the PTP infrastructure, any control, any SDI infrastructure, that was all out of scope of the actual testing. So network was a given, like we assume that it's performing well. Same goes for PTP. Of course, we monitor it, but it was not like this switch is now certified for 2110. It doesn't work like that. So end devices were tested for the control plane, but of course the actual panels, the actual controllers, the registries is a big part of the equation, and we will look into including them in the future testing. ISO 8 and configuration consistency between the SDP and ISO 4, ISO 5, this is very important things. More serious PTP testing also. PTP is a big part of the equation. We assumed a lot of things were given, but we will look into testing more of PTP related tests in the future. We're looking into, and you can learn about the last bullet point, which is pod approach can be deprecated in favor of full routed network. If you attend my talk tomorrow about the network automation, I'll be actually saying how we were running the network for the testing, and we had the concept of a pod. So it was mainly a layer 2 network, and we had a separate subnet and a separate VLAN for the testing. So we relocated device into different subnet. Right now, as a good practice, we're looking to having a fully routed network. So every single port is not a switch port, it's a routed port, so the network is completely layer 3. And by doing this, the devices will be isolated by design, and we will not have to have a hassle of moving and reconfiguring them. Improved result compared to the first tested event, as I said. The industry starts to see the need to a common control plane, simply because they saw how quick it is to test if the control plane is fully implemented. Mandatory self-testing is essential, and we saw a lot of improvements because of the introduction of the mandatory self-testing. This event may need to be repeated in order to get better quality implementations, of course, because it's driving the vendors to improve more and more and to adopt more and more of the open standards, but also to include even more layers of the pyramid, because the users demand the full pyramid support, of course. And the value that we created, getting current state of the implementation, so again, a snapshot in time, you get it and you can read it. Improving the implementations, obviously, and safeguarding of the investments, because we do this for you guys, for the end users. Should you be an EBU member or working for an EBU member, or as a bystander even, and you think about building an IP solution, you can still benefit from this by going on this website, downloading the catalog. Should you be using the actual catalog, that's fine, and the actual results, that's fine. But you can also read the task plan to just educate yourself how you should be testing those devices and benchmarking them in your particular use case for your particular situation. So again, do scan the badges, get the slides, read about that, educate yourself, and get the documents. And I thank you very much for your time.